This video will be about the tangent ratio. So the tangent ratio only works for right triangles. And when you have a right triangle, it has to have one angle that is a right angle, hence the name right triangle. So what the tangent ratio does is it compares the angles to the sides of this right triangle. So they have to tell us what angle to look at. So let's say we're looking at angle A. If we're looking at angle A, from there we have to decide how do the sides relate to angle A. So looking at this picture, one of these sides is always called the hypotenuse. That would be the side across from the right angle. So that is our hypotenuse of our triangle. One of the sides we're going to say is opposite angle A. So that's also across from angle A. And then the last side we would say adjacent. It's next to angle A. So let's say I took that exact same triangle, but I said let's look at angle B. Hypotenuse would stay the same because it's always across from the right angle and that hasn't changed. But opposite and adjacent could change because if we're looking at angle B, the one across from angle B is now the left side of our triangle, where before it was the bottom, which means the last side here, the bottom, would be the adjacent. So once we're able to label our triangle and identify, okay, this is what we call the hypotenuse, this is what we call the opposite, this is what we call the adjacent, then we can use what's called the tangent ratio. So our tangent ratio is the formula tangent of the angle. That is not times. I know we're using a parentheses here, but in this case we say of. It's something you'd actually plug into the tangent function. Tangent of the angle is opposite over adjacent. And I'm just going to put OPP for opposite and ADJ for adjacent. So let's look at an example. This time I'm going to switch things up and change the orientation of the So let's say I ask you to find the tangent of angle y. And I should give you a little more information. Let's say the sides are 3, 4, and 5. So if I'm going to find the tangent of angle y, first I have to identify the hypotenuse, opposite, and adjacent. So I always start with hypotenuse because that's the easiest. Across from the right angle is 5, so that would be the hypotenuse. Then the angle we're looking at is what they tell us right here, tangent y. So we're looking at angle y. So across from y would be considered our opposite. Since they told us to focus on y, that's the angle we want to find the side across from. Finally, the last side would be adjacent. So now we go plug this into the formula. We know we're trying to find tangent y. They already told us the angle, so we've filled this angle spot. We just have to fill in the opposite and the adjacent with the numbers that go with the opposite and adjacent. So we said opposite is 3, adjacent is 4. So tangent of y equals 3 over 4. That is our answer. It is possible you may need to reduce this fraction, but there's nothing that divides into both 3 and 4 except 1, so we can leave it as it is. So that's our first possible way to use this tangent ratio. The second way is if they give us the actual angle as a degree measure, say this is 23 degrees, and then they want us to find one of the sides. So we're going to use tangent to find x. We still stick with that formula, tangent of the angle equals opposite over hypotenuse. But this time when we go to fill in the angle spot, we'd have to actually use the angle measure of 23 degrees. They gave it to us. We should still decide what's hypotenuse, what's opposite, and what's adjacent though, so that we can figure out the right side of this formula. So across from the right angle is hypotenuse. The angle is given inside the triangle now. This time we didn't have to figure it out from the formula. We say, okay, 23 degrees. Across from that is x, so x is the opposite, and that would leave 5 as the adjacent. So we go plug all that into the formula. Tangent of 23 degrees, that's our angle, equals opposite over hypotenuse. Opposite is x. Hypotenuse, sorry, that should have been opposite over adjacent. Adjacent is 5. Notice the hypotenuse wasn't used at all, which is fine. For tangent, we don't need it. So now the question is, how do I solve something like this? Well, our goal is to get x alone, so we have to do opposites. If we're dividing by 5, the opposite of dividing by 5 is to multiply by 5. So we're left with 5 times tangent of 23 degrees. Now that's not how your answer is going to look though. And there's no way for us to find tangent of 23 degrees without a calculator. So now you must use a calculator. Every calculator is a little bit different as to the order you actually plug stuff in. They will provide a calculator in the program itself, or maybe you prefer using an online calculator. There's a bunch of different options. I'm going to go ahead and use the basic calculator on the computer itself. If you're going to do that, and I don't know if Chromebooks have these, but most laptops have a basic calculator you can use. You want to go to View and change it to Scientific because we need to have a tangent button. So first of all, you need to make sure you're in degrees. If you're using the program's calculator, it should already be in degrees. Then we're going to go plug this into our calculator. Some of the nicer calculators will let you just plug it in exactly in order. You could type 5 times tangent of 23 and hit enter. This calculator, we kind of have to do it backwards. We have to go tangent, or 23, then hit the tangent button, and then we times by that number in front, times by 5. So 5 times tangent 23 is 2.122. And most of the time it'll ask you to go to the first decimal place, the tenths. So if I were to round this, it would round as 2.1. So the next thing we can do with tangent ratio is similar to what we've done. So I want to find x again. We know across from the right angle is hypotenuse. Across from the angle given is opposite. And the last thing is adjacent. We know the formula for tangent is tangent of the angle equals opposite over adjacent. And we go plug our stuff in. Tangent of 65 degrees equals opposite, which is 8, over adjacent, which is x. So the start of this process was exactly the same as last time. What's slightly different is how we solve it. Notice now we have x in the denominator. That's a problem. When x was in the numerator, it made it a little bit easier for us. But since it's in the bottom, we have to get it into the numerator first. So we're going to have to multiply both sides by x just so we can get it to the top of the fraction and not have a fraction at all anymore. So we'd have x times tangent of 65 degrees equals 8. Now our ultimate goal is to get x alone, so now we need to get rid of tangent 65. Since we're trying to move the whole thing, we're using the opposite of multiply, which is divide. We're going to divide both sides by tangent 65 degrees. So that means x equals 8 divided by tangent 65 degrees. And again, we're going to have to go plug this into our calculator. So on this calculator, I'm going to clear it out. This time I have to do it a little bit differently. I'm going to go 8 divided by, and then I'm going to have to put parentheses around the stuff at the bottom, or else it's going to do some of the operations too soon. Again, if you have a different calculator, you may just be able to plug it in straight in the order that it's written, 8 divided by tangent 65. So we're going to have to do 8 divided by 65, and then we hit the tangent button, close the parenthesis, and then hit equals. So that gives us 3.73, rounded to the first decimal place would just be 3.7. So the last thing we can do is use the tangent to find an angle in a triangle. Let me restart that. We don't want the angle. So let's say we have this triangle, and I want you to find the measure of angle A. So we're still going to be using tangent, which means we still need to do a hypotenuse, opposite, and adjacent. So across from the right angle is hypotenuse. Across from, since we're looking for angle A, across from A is 8. So that would be opposite, and then the last one is adjacent. So we know tangent of angle A equals opposite, which is 8, over adjacent, which is 6. Now in a previous problem we stopped here because it had asked for tangent A, which this would be our answer for tangent A. But if it asks for just A, that means they want you to get rid of the tangent part. They want that to go away. Now that's a new thing, and we don't have an opposite for it right now. So the opposite of tangent. So when we have, say, opposites, like opposite of addition is subtraction, opposite of multiplication is division. Those are all opposites. Opposite of tangent is called inverse tangent, and it's almost the same symbol. It's tangent with a -1 in front of it. And it's weird because we put it in front of the whole thing. On addition and subtraction, or multiplication and division, we're used to putting it underneath. Here we put it in front. Same thing on the other side. What you do to one side, you do to the other. So what this opposite is going to do is it's going to get rid of the tangent and leave you with just the letter A. And that's what we want to happen because we want to know what is angle A. So on the other side we have tangent inverse of 8 divided by 6. We go back to our calculator. I'm going to plug in 8 divided by 6 first, get an answer. Then I'm going to use the inverse tangent button. Now right now, there is no inverse tangent button. So often you have to hit another button for it to show up. Here you see INV for inverse. I've got to hit that first, then it will show up. Sometimes they don't even make it show up. They just assume you know that if you hit the inverse button, oh, inverse tangent would be above the regular tangent. Okay, so that means angle A is 53.13. Now this one they often say to the nearest whole number. So we look at 3, that's either going to stay a 3 or go up to a 4. The number next to it is a 1, which means we stay at 53 degrees. So that completes our discussion on the tangent functions.